Thank you so much for taking the time to be here. I'm Ramya, staff software engineer from the performance engineering team here at LinkedIn. And out there is Angela Deng, my co-host. She's also from the performance team. About a year ago, we started organizing a quarterly meetup for building and fostering the performance engineering community in the Valley. And since then, the community has grown a lot and benefited quite a bit from each other to the extent that we've had a record turnout today in spite of the rain. So thank you all, guys, very, very much. At LinkedIn, we are a central performance engineering team. A little bit introduction about our team is that we build centralized tooling and infrastructure for the entire company, which means each of us get to have a significant impact on all of LinkedIn's products and services. We have a number of exciting initiatives that we are running, ranging from shifting left to have continuous performance testing throughout the release pipeline. We constantly experiment with new modern performance technologies across our stack. And we look for innovative ways to have real user, real monitoring, real data monitoring at scale. So needless to say, we are hiring, and we constantly look for engineers that are passionate in building centralized tooling and optimizing our stack for a company growing at our scale. So if that sounds like you, please reach out to us. In the past meetups, we've covered a variety of topics, ranging from our tooling and our own experimentation infrastructure, the trade-off between Chrome browser and stability and security, so how server-side load balancing impacts our front-end side speed, and flame profile visualizations. We've covered speakers from a variety of companies in the Valley. And thank you all so much for giving us the feedback and giving us ideas for future talks and content and poster presentations. So we constantly strive to tune the content we provide here to your benefit. So please continue engaging with us in our community. The videos for this talk will be posted in our LinkedIn performance engineering group. Please join the group so you can catch a recap. So that said, let's get the talk started for today. Our first speaker for this evening is Marty Grinia. Marty works on web and mobile performance at Facebook, where he has worked on a variety of analysis, tooling, and infrastructure projects over the years. Having operated as a perf engineer on both mobile and web, he's currently focused on unifying the performance tooling experience for all of Facebook's major platforms. Marty Grinia, everyone.
Cool. Can you hear me?
Yes.
Excellent. Can we go back to the start slide? Oh, cool. Welcome. My name is Marty Grinia. As Ramya said, I'm an engineer. I work on web and mobile performance at Facebook. And in particular, the tracing and the tooling has been a big part of what me personally have been focusing on over the past year or so. Probably what we'll continue focusing on for the near future. And kind of wanted to come and talk a little bit about sort of what we're doing and kind of what I mean by this, and maybe give a couple learnings and things that we learned along the way. And obviously, it's going to be a lot for 15 minutes, so feel free to come up to me afterwards and we can chat during happy hour. Cool. So what do I mean by performance tracing? At Facebook, probably like many places, we kind of cluster our tooling and our measurements into two buckets. Kind of on the high end, we've got really lightweight, high volume stuff. It's cheap to log. Usually it's a latency, how long a startup took or how long an image took to load. This is really good for monitoring and tracking performance. But other than that, if something goes wrong or you're trying to make something better, these are usually too superficial. Then when you go a little bit lower, this is kind of in the performance tracing territory. And this is kind of what I really want to focus on for this talk. This is where you want CPU, you want disk, you want network, you want all kind of the nitty-gritty details that will help you basically understand why something's slow. But the challenge there, of course, is that you also don't want to sample everything. It tends to be more expensive. You want smaller quantities of data. Also, once you get the data, it's hard to grok. You can't just take an average of it. It's usually a complex trace. So this is kind of the space that I'll be talking about in here, in this talk. There we go. And in particular, at Facebook, as in most places, the tooling has kind of evolved naturally over time on all platforms, iOS, Android, and web. And about a year ago, we were kind of at this point when we realized the tool sets were kind of similar if you squinted at them across the different platforms. But an engineer who went from Android to web, for example, or from iOS to Android, it wouldn't be just like a copy-paste experience. You'd have to kind of relearn the stuff that was there. And this is part of the motivation that led us to actually unifying these on all platforms. So I'll kind of walk through some of the experiences here. But before I get into details, this is like a superficial overview of what our platform looks like today. All of the tracing policy decisions are basically defined on the server. Engineers can basically input these to the tool. Policy basically gets sent down to the client to enforce. If tracing is enabled, we decide to take a trace of a particular interaction. All kinds of useful data gets logged to the trace. When the trace is over, it goes up to the server, a little bit of conversion, symbolication, all that stuff happens. Store it into the database, and then all the tools and things like that can suck traces out kind of as needed. On a super high level, I'll go through some of the more interesting details of this now. In particular, I want to focus on 4 big things: tracing policies, trace providers, formats for the traces, and then finally, my personal favorite, automated trace analysis. So tracing policies is kind of what starts the whole process. And sort of the options available to you are pretty similar regardless of what platform you're on. This obviously controls what to trace and when to trace on the client. It involves what platform specific trace providers you want, CPU, network, disk. I'll talk about that in a later slide. Also the constraints on maybe like device type, or if you want a specific network condition, this is something you can configure. And also the trace sampling policy. We support probabilistic sampling, so if you want maybe 1% of startups, you can collect 1 out of 100. But the tool also supports defining a rate. So maybe regardless of how many users you have, for your purpose, maybe you only need 1,000 traces a day. That's just your situation, which sounds not too bad on the surface. But if we dig into that a little bit, this can be reasonably difficult depending on the situation. It depends a little bit on if you're trying to trace a page load or if you're trying to trace something either mobile or web on the client, where it's a client-side interaction. You may not even involve the server necessarily. So let me explain a little bit why with a picture. Everyone loves pictures. So here's sort of the web page load experience. You go facebook.com in your browser, you push enter, browser hits the server. And here, kind of the server has the chance to sort of do the coin flip and decide, do we want to trace this interaction or not? If it's a really complex policy, you can kind of go through that. If you're trying to do, again, maybe 1,000 traces a day, you sort of have all that state there available to you. So this is actually relatively straightforward. If you decide to trace, when you send responses down to the client, you can just say, hey, basically do your tracing while you're down there on the client. However, this gets a little more complicated, or actually more complicated, if you're looking at either a mobile trace that's initiated on the client or a web trace, like a JavaScript interaction. Because the challenge here now is all those policy decisions essentially have to be baked into the client. So on the one hand, this is a kind of a hassle from an implementation perspective. You need to have kind of all that logic replicated potentially. But also it gets really weird for that previous case I just mentioned. If you want to trace 1,000 times a day, if there's 1 million people doing this, or if there's 100 million people doing this, like the client needs to know, am I going to trace? Are you going to trace this particular interaction? which, a client by itself is tricky to do. However, it turns out we know, roughly from our logs how often somebody does let's say a startup yesterday over the last 24 hours. So we know if we wanted to collect 1,000 traces, we know roughly what sampling rate we would have needed previously to hit this trace collection target. So therefore, it's actually not too bad of a stretch to use that sampling rate going forward over the next 24 hours, over the next hour even. And basically, the sampling rate needs to be dynamic, but you can actually pretty reasonably adjust that over time using some really basic math and basically building up towards this trace target. A little complicated. We can talk about it offline too, if anybody has questions on this. So next topic I want to talk about is the trace providers. This is kind of the bread and butter. This is the actual data going into these. And on the client, we use the Profilo framework, which you can check that link there. And that has a little bit of detail on the Android version. But the net effect, or the big benefit of this here, is that you can plug in all kinds of different data and trace providers into this framework. And when a trace starts, basically the provider is required to just log their data using a simple API. When the trace ends, the trace provider can end. And then it all obviously gets sent up to the server. But it's plug-inable, and it's really easy to add new types of trace providers. So the platform, kind of the experts on the platform, are able to kind of add the providers that they find most useful for their particular use case. And in principle, or in practice, we've found kind of 3 big examples of trace providers that have gone well kind of across all 3 platforms. CPU time is pretty much always useful, regardless of iOS, Android, and web. Just catches anything that you might be missing, and in general, just keeps things, it's a really good way to find things you're missing. Network requests, likewise, if you're doing a whole bunch of network requests, being able to log that and see if you're doing a bunch in sequence or in parallel is really useful. And then startup is one of the more important interactions that we care about at Facebook for our apps. But each platform has actually fairly different metrics that we log for that, which I'll describe in a slide or two. Let me give you a quick example on how we do CPU sampling across the different platforms. So on iOS, this is actually pretty easy. We can register a signal handler, set up a timer to fire every, say, 10 milliseconds. When the timer fires, you can grab a backtrace, you can log those pointers, do symbolication later on the server. On Android, this is similar, at least for native code. In Java land, you have to have a little bit of extra care to handle the Java stacks and unwind things properly, but ultimately not too bad. JavaScript is where things get really kind of awkward. There isn't a nice kind of analogous way to do this in JavaScript land. So one of the things we've done is actually instrumenting functions. If you decide you want to basically take a JavaScript time trace, we can add entry and exit stubs to the functions. And if we sample, we can flip those on and log it to the trace buffer. But because this is kind of quirky and kind of janky, this is motivated that, if you look at that link later on offline, this is basically a JS profiling API that we're working with browser vendors to include at some point. And the hope is to push this into the browser itself so that we don't have to try to do it on the JavaScript layer, but we can still get really useful data back. Cool. So startup metrics, I'll give another quick example on this. On Android, class loads correlate, or poorly, I guess. More class loads is usually worse for startup performance. But it's relatively easy to instrument, and we have that. If class loads go up, we can basically dig in, look for regressions. Page faults on iOS is a little bit harder to get. We know page faults correlate, again, poorly with startup performance. More page loads, page faults, the worse. However, you can't just instrument every single page fault. There's no API in the kernel to do that. So instead, we do sort of a sampling approach, where every 50 milliseconds, you can get the page fault count from the kernel and just sort of do the deltas yourself and just look for interesting increases over time. And again, on web, this is a little bit more difficult. There's not a lot of kind of performance metrics that we would want to get from the browser. So more often than not, we end up just relying on JavaScript size, which again isn't perfect, but tends to correlate pretty well with parsing, compiling times, things that there's no explicit metric that we would want to grab. But yeah. All right, so let me talk through this real quick. It's kind of unintuitive, but Profilo, basically our client-side tracing, and Canopy, our server-side tracing, have different formats. And it sounds kind of weird, like why would you have two different trace formats? Like, isn't that kind of a hassle? You have to convert from one to the other. But as it turns out, this made a decent amount of sense for us, especially on the client in mobile. This decouples the client and trace formats. So, clients can kind of change on their own schedule. The server can change on its own schedule, and you have that sort of indirection there. Also, we need to symbolicate client traces most of the time anyways. So it's kind of not as much work as you might think to have this extra step. And also, the traces have different purposes, which I'll explain what that means. So Profilo traces, I kind of think of them as like a dumb pipe. This is just a buffer. You want to store all the data and all the metrics you need kind of as concisely and easily as possible. Humans never have to see this. The Canopy traces on the server are kind of what we call semantic traces, which is they sort of have a concept of like execution time and traces and CPU time. So this is actually what engineers want to work with and what the tools and such are based on. So here's a really quick example. This is not a real example or a real trace, but kind of representative. On the left, on the client, for our CPU sampler, we're logging stack traces every 10 millisecond, and it's just literally just a stream of samples. When we get to the server, though, we want to convert it into what we call blocks, which is basically a region of time, start time and an end time, and has the function name associated with it. And semantically, this makes a lot more sense to a person viewing this trace. From there, you can also draw like icicles, or you can draw flames. And this is sort of the format that the tools want to use, or rather the tool developers want to use when they're creating their tools. So different purpose, kind of different audience. All right, so last section, automated trace analysis. This is one of my personal favorites. Imagine you're collecting thousands or millions of traces a day. You don't want to be looking through those all manually. That's just too much work. There's no way you would have enough time in the day. So the system supports writing Python. You can write Python to kind of analyze your traces. You can query various characteristics, how long a thread time runs, how long disk I/O takes. And from here, you can do a lot of really cool stuff. Critical path being one of the more obvious examples. If you know a block of time takes this many milliseconds and schedules block B and schedules block C, from there you can kind of compute this kind of a graph that says this is the critical path. Kind of everything else is not really related. And basically this red is what you want to optimize. And one more quick example. I have the same trace, and maybe I'm sick and tired of looking at a million traces a day. I just want you to kind of give me the summary. What are some of the highlights of this trace? You can write a little Python. Maybe you're measuring what the longest thread is. Maybe you're measuring how many concurrent network requests you have. You run this over a million traces, dump it into a data set. Now you actually have data that you can do some kind of aggregates. You can look at averages, correlations, and see, in this case, 9 concurrent network requests correspond with the longest total latency. So you can kind of do some cool aggregate stuff, and you still have the traces on the back end if you want to look one trace at a time. So conclusion, each platform is different. Keeping the client tracing framework flexible really let us add the data that we needed for the platform and the engineers that needed it. But at the same time, a lot of stuff was similar across platforms. So using similar tracing profiling logic and similar back-end tools makes it easy to kind of not have to replicate everything 3 times. And collection analysis, also sort of splitting that up, gave us a lot of flexibility as well. There's a bunch more details online. Most of the information is covered in detail on either of these 2 links. But I guess we have a little bit of time for questions. I don't know if we can go back. There we go. Oh, no, I don't. A couple minutes for questions. Actually,
We have the microphone up the back here as well. If
there's a mic in the back.
Please line up at the back.
So on one of your slides, there was a graph of dependencies between concurrent blocks of code where like one block waits for the other one to execute. Did you instrument multiple threading libraries to collect that graph, or you managed to collect it from stack traces, maybe with additional
Good
data?
question. I kind of glossed through it, but the text on the slide had it. So on web, this, especially on server, it tends to be easier, and on web, it's not so bad because you do need that connection, A scheduled B scheduled C. So kind of anything that can schedule something asynchronously or even a network request, you need to have that hook in there. On mobile, this has actually been kind of tricky to do because especially Android, there's just like so many different ways you can schedule something. And if even one or two of them leak out of the garden, then the whole thing kind of falls apart. So definitely more of a web server thing, and on mobile, it's been a little more hit or miss. Any other questions? Oh, I guess we'll do the microphone. Yeah, if you want to go to the back.
Hi, thanks for that. Mark Curini, Mark Logic. Do you, so I know that basically speaking, trace providers are generally very low latency, but do you ever encounter situations in which you need to back off with your sampling rates or things of that nature, especially like when there's a confluence of events either on the server or on the clients?
Yep.
I mean, probably less so on the client.
For sure. I think probably my best example of this is for the CPU profiler, because sort of the impact of a CPU profiler, you can dial it in based on your frequency. If you take a sample every minute, no one's going to care. If it's every 10th of a millisecond, you're probably in trouble. So like, especially for that one, because it is so dangerous, we have a special knob for that, and we try to keep it above a reasonable threshold. But if it's something cheap, like, I don't know, logging network stats is usually really cheap because there's not that many, then we would just log it for every trace, basically.
So what is the overhead of the tracing on the client side? I mean, what is the size of the payload that gets sent back? Do you compress it, or do you do anything to?
Yeah, we compress it. And also the Profilo payload itself is designed to be kind of small. There's some delta encodings and stuff in there. I forget what we picked as our goal. It's been a while since I looked at it. I want to say it's in like the tens of kilobytes, but don't quote me on that. Does that answer your question? Sorry, that wasn't super helpful.
Yeah, and if it's there on the client side, is it something that the user opts in for, or is it something that happens with all the clients?
In general, it's random. Aside from certain special instances, it's just like a random sampling. So we specifically want to avoid like just hitting one person 1,000 times a day. All right, I think I'm getting the signal. Thanks for questions. Feel free to come ask me at happy hour. Oh, okay.
I can imagine how such a unified tracing experience can be a very welcome experience for the developers debugging performance issues. Thank you, Marty. Our second speaker is Brian Wilcox. Brian is a site reliability engineer at LinkedIn with the Waterbear Resilience engineering team. His primary focus is on automating infrastructure application and building chaos engineering tools to test resiliency assumptions. Brian Wilcox, everyone.
All right, let's jump right into it. So at LinkedIn, we use a nearly universal RPC that we call RESTly. It consists of two big parts, R2 and D2. Yes, we're nerds, it's true. R2 is responsible for object exchange. This is what is the URL, what is the schema, what is the location, what's the actual piece of hardware that we're communicating with, as well as what version of this object am I retrieving, what version of objects am I sending, that stuff. D2 is responsible for service discovery and configuration declaration. I split those up because service discovery is, I'm trying to find profile, do tell me where that lives, and you get back that list. But configuration declaration is a little bit more meta. So within R2, we can say this connection that you're establishing, you should expect it to be returned. But when? how fast, what time, what kind of penalties do I apply to this downstream node if it doesn't comply with the conditions that I specified. And all of that's within D2 inside the configuration declaration. Then additionally, as part of this whole RESTly framework, we have metrics and filters. So LinkedIn specific, anybody can add filters, but the LinkedIn specific filters, this is where we do service-to-service authentication. This is where we do metric emission. This is where we do distributed call tracing. And this is also where I do my chaos engineering. So all this is up on GitHub. You can check it out. There it is. But the point that I want to bring to you today is we have two components that we focus on that really make a difference. One of them is adaptive load balancing. I'll get to the other in just a moment. Adaptive load balancing, the way that this works is that we rely on the client to do the load balancing, not the server. So if we have, let's say, 10 upstream clients, let me roll that back. The upstream client, if we have 10 downstream nodes, there we go. And each of those downstream nodes come online, they join what's called a hash ring. And a hash ring is essentially a number line from 0 to a big number. You pick the big number. And then we allocate each node of the downstream cluster in the client side a location on that number line that says, if you get this number when we do our random number generation or our hashing mechanism or whatever we're doing, then you should go to node A or whatever. So what this looks like is with 10 nodes, and each of those 10 nodes have 100 points in the hash ring. 10 nodes, 100 points, that means we have 1,000 points in the hash ring. Cool, right? However, if we're starting to remove or add those points in the hash ring per node, we can change the distribution to each individual downstream cluster member just by manipulating that hash ring. This is really good because this allows us to do adaptive load balancing, capacity testing, ramping up new traffic to a node, a whole bunch of really cool things. The problem is, if you set this value too lenient, let's say we have a threshold and our service is never going to hit that threshold unless something is catastrophically wrong, then I'm always going to have equivalent number of points in the hash ring per node, which means I have round robin. It's not quite round robin, but it's pretty dang close. And round robin suffers from a great many problems with load distribution. Same thing with too tight. If I set that value below what my normal speed looks like, if I'm at 500 milliseconds and I drop it down to 150 milliseconds, then I'm always going to be constantly degraded. I'm always going to remove as many points from the hash ring as possible, which you may say, oh my gosh, my cluster is going to go dark. No, 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 no. What it is we have 1 point in that hash ring. That's the minimum number you're allowed to go. But again, if every node in the cluster has the same number of downstream points in the hash ring, then you get round robin. So what we're looking for is that Goldilocks zone of where we're 90% degraded for that cluster. This means that as soon as something goes into garbage collection, as soon as there's a network anomaly, after 5 seconds, which is how often the degrader rolls, it'll drop points in that hash ring automatically, and all the clients shift traffic away from the naughty node. But we also have timeouts. So timeouts matter a lot too. We can't just degrade, we have to degrade aggressively and we have to drop things very quickly. This is where performance comes in. So this is from the client side. From the client side, how many resources am I consuming by communicating with a bad node on the downstream cluster? That big fat red line, that is how many resources we're consuming on the client, and that second less red line is the number of QPS sent to that downstream cluster. Now, by default, LinkedIn and RESTly itself has a code that says, hey, at 10 seconds, that's the top. Nobody should ever be slower than 10 seconds. Seemed like it's the same default, but really it's a safe default, and I'll get to those a little bit later too. So at 10 seconds, we start realizing that our requests are being spent. And that graph, you can see, goes up to 1,200. Now, 1,200 is the number of open Unix sockets. It's the number of open TCP connections. It's the number of threads if you're using JettyNetty. It's the number of CPU memory allocations if you're using Play. It doesn't matter. The point is keeping those resources alive, communicating with a garbage node, uses up some measurable resource. So at 10 seconds, we realize things are busted. Now, the degrader kicks in every 5 seconds, evaluates the requests, and says, okay, in the last 5 seconds, how many requests have I received that are garbage? In this case, what we end up with is 44 seconds of impact. That's 44 seconds of users being affected by this slow request. It's 44 seconds of garbage site speed. And it's almost 3,000 requests that the user is never going to see because it timed down. Now, Same exact equations, same exact degrader timeouts, and the only thing that we do is we change the timeout from 10 seconds to 1 second. This is good. It means that right after 1 second, we start dropping those requests that we're piling up. We still have to wait for that 5-second window because degrader is doing its thing. And then we can see that we drop off. So a couple of things worth noting here is that 28 seconds, that's our total impact window. We cut off 1/3 of the impact window. That's good. We cut off 1/3 of the requests. Also good. Still suboptimal, but what's most important to me is the number of threads used in the upstream cluster. We go from 1,200 threads used to 240 threads used. This is all because we want things to be properly tuned, not just for timeout, but also for those degrading values. So back there you see those are just one of the set of configuration files that Restly has in it. It has a lot of configurations, and unfortunately, that means that it has a lot of values to be passed in. We chose a lot of safe defaults, things that we said, okay, it should never be greater than this. But there's a distinct difference between safe default and sane default. Sane default says you shouldn't cross this, but we'll let you cross that easily. All you have to do is manipulate this, either justify it in a change request or some other mechanism. But because we have so many values in here and because we set them at safe values all the way down off yonder, people didn't configure them. And so even though our software is only as good as our documentation, and our documentation was excellent, developers were not building their systems and configuring them the way that we hoped they would be. 90% of our services was still at those 10-second timeouts, and this was taken about a year ago. And 97% of online requests were affected by nodes known to be misbehaving. Now, affected is in those terms because it's very hard at this point to say that this is direct causation, and we only have correlative data. But what we can say is that we know that the number of requests we're hitting at least one in our entire fan out of our graph, we're hitting at least one node that we knew to be misbehaving. We would retry that request after a period of time. We would do something intelligent with it. We would return default data. But regardless, the point was we could optimize up to 97% of our requests. And our updates to these configurations were being driven specifically by site incidents, not by general hygienic practices. How many people are like, yes, today I'm going to optimize that config? Maybe in this room that's probably a bad example, but in general, that's not something that engineers really want to do. So what did LinkedIn do about it? We built D2 Tuner. So this started off as a dirty, rotten command line script out of Python, but we've evolved it since then, and now it actually has a nice little web UI. But the idea was we codified generational knowledge. We went to the people who had good configurations and we said, please, sir, do tell me what you're doing right. Please, madam, tell me why your systems are good. And they would give us their example of what they thought they did to achieve these good values. Now, the spectrum on what we did here was truly awesome. There were some people who said, well, I feel like this is the right number. I'm like, I can't codify feels. But what we did is we came up with numbers. We started taking that information. Every time there was a new hire, we would make sure that that new hire wrote down in the wiki any steps that they took that had anything to do with this, because we found a lot of interns started their days doing code work that was config work. And so a lot of people starting their jobs here at LinkedIn were doing that thing where it's like, well, this is safe. Let's put the newbie on it. So the idea was, how do you do the thing? Whatever the thing is, whether that's optimized garbage collection, whether that's optimized thread utilization, whether that's optimized the system performance, what do you do to do the thing? Can I write that thing down? Because if I can write it down and give it to an intern to do, I should be able to automate that. And then, can I make the program go as fast as possible and do this thing over and over again and don't need the human to do this anymore? We also started with something that's achievable. As I described earlier, D2 timeouts, degraders are very safe. It just turns everything into round robin, no big deal. If I turn everything into timeouts where we actually start dropping the requests, big deal, right? So start with the achievable. Find the place that you need to do so that you can make sure that the people trust your system. Measure the impact. This is the number of errors that we had per week. I can't show you the X or the Y, so you get to guess. But the intention is, as a team that's sitting on the bottom of the infrastructure, it's very difficult for us to feel good feelings about what we're doing for the users. So if I can measure the impact and I can say that's the number of people who didn't get kicked out of a job because they were trying to apply and it screwed up, or made the right connection, that's really impactful for the team. But also it helps me as a team leader and a manager get resources for the team. See the good that we're doing here? Please give us more resources. And it makes it very easy to figure that out. So, make your performance applications approachable. If the users aren't using your application correctly, it's not because the users are lame, it's because you need to do extra work. Is your documentation up to date? Is it an enjoyable experience? Is it pleasant to do? What is the thing that you need to do to draw your users into the appropriate funnel? Give it away for free. When we made changes, we didn't say, hey, you can have that change if you do this implementation. We said, here's the implementation. We've done it for you. Just hit this button that says, I approve. And automate all the things. If you can codify it, if you can figure it out, if you can write it down on a wiki, you can optimize it and you can automate it. Done. Oh, it's either so good or so bad. I'm not sure which one. Mike?
So this looks like a dynamic version of consistent hashing. Is that right? I mean, so.
Yeah, so the load balancing is a dynamic version of consistent hashing. That's correct.
And with D2 tuner, you sort of codified a lot of, I guess, tribal knowledge into the scheme that actually does this automatically.
Absolutely.
So leaving that aside, I mean, with regard to the rest of the infrastructure, is there some automated way that the system actually figures out that certain nodes are in trouble and basically removing those automatically, without this other,
Yeah. So the D2 hash ring is the lord of all things as far as LinkedIn load balancing is concerned. We do have mechanisms that automatically detect if this node is misbehaving in the sense that it's throwing 500s or its latency is above those thresholds, and we can reduce it to 0. But also there's another configuration, which again we're going to be optimizing soon, that will allow that a certain percentage of your cluster to drop to 0, and then it will only do heartbeat checks. Because the only way that you can add points back into the hash ring is if you receive live traffic to say, yes, I'm ready, and then those values come back. So with D2 quarantine, which is an extension of kind of some of the work that was already done, you can drop that down to 0 and say 10% of my cluster can go dark if it's behaving poorly. But we would need to really be careful to say that we should remove nodes entirely. Otherwise, if there's a major network event, let's say one of the switches starts doubling the latency, now the entire cluster goes dark, and how do we get it back?
Yeah, that definitely makes sense. So the parameters in D2 tuner, I mean, they are applicable right now for, I guess, LinkedIn's workloads, but externally, would changes be necessary to that? I mean, people needing to.
So if anybody wants to adopt Restly, you can already adjust these configurations. They're already out there. All we did was consume production metrics, use statistical analysis to remove anomalies or error times, and say, we believe that this configuration should be applied to Restly. And that process of taking it from our analysis and applied to configuration is what we automated. As far as whether or not D2 Tuner is public, it's not public. The big problem is your metrics pipeline and my metrics pipeline are not even close to the same. But the statistical analysis is going to be open sourced when we moved it into offline data.
Cool, thanks.
Thank you.
Thank you, Brian. So for us in the perf team, it was particularly interesting to see how simple low-cost changes, such as just changing the timeout in the D2 configuration, made such an impactful difference in upstream resource consumption. So yeah, just automating such changes is the only way we can scale such one-off optimizations without scaling our team. Our last speaker for tonight is Llya Grigorik. Llya is a web performance engineer at Google, co-chair of the W3C Web Performance Working Group, and author of the O'Reilly book, High Performance Browser Networking. He also aptly calls himself Internet Plumber. Llya Grigorik.
Thank you. All right, let's see if this works. Woo, all right. So I work on a number of different efforts within Google, but one of the main focuses is working with the Chrome team on the web platform, and that's where we overlap with even some of the work with Marty on JS profiling and a bunch of other efforts. One of the issues or one of the challenges historically that we've had is just talking about and measuring how is the user experience on the web actually. We have lots of anecdotes and lots of data or case studies rather of great successes. Like we can publish great case studies, we feature them, we promote them around better increased conversions, improvements in speed leading to better user engagement and all the rest. But at the same time, there is a lot of material available out there that shows that the web is actually doesn't quite live up to what where it needs to be, right? So it is in fact a popular sport to snipe at the web and declare the web dead or dying. And I think there's some truth to that. In fact, there's a lot of truth to it. It's certainly when you look at the zeitgeist, you see a lot of people complaining about the web being slow, the web not meeting the user expectations, all those ads popping up or pop-ups or other things. So there's definitely something there. And the big question that we have on the Chrome team is, how do we quantify this? How do we actually measure if the user experience and all the work that we're actually doing in the web platform is actually moving us in the right direction? We can point to great examples and we can shine the light on them and try to kind of spread that gospel to the rest of the web. But there's definitely lots of dark corners of the web where a little bit of light could help to help us understand where are the problems. So in Chrome itself, we can actually answer this question. So I don't know how many of you guys are familiar with Chrome histograms, but if you just open a new tab and type in Chrome histograms, you'll land on a new page that has thousands of histograms, and it effectively shows you all the things that Chrome tracks internally for all of your navigations. And thank you. And what happens is we then periodically just sync this aggregate histograms to our servers to see kind of the overall state of the web. So you can look at this. This is based on your own browsing history, and there's lots of interesting stats about, like if you want to answer how is your user experience on the web, you can open that, look at it, and get a pretty good picture. In the aggregate, historically, we've been able to collect some of this data to look at the web at large, and that's been incredibly useful. But of course, because the data is so aggregated, it doesn't allow us to do any sort of causality. We just see general trends, like the web is getting, or this particular metric has shifted this way after we released a new version of Chrome. That may be a cause for concern or maybe not. So there's some challenges there. So what we really needed is a more granular way to track on a per origin basis how's the web doing. And that is what the Chrome User Experience Report aims to solve. So this is an effort that we announced about a year and a half ago at Chrome Developer Summit. And the goal here is to gather real-world user experience data as users use Chrome and browse the web, and make that data publicly available for the rest of the web so we can actually have an informed discussion around, are we making the web better, or is the web getting slower or faster and across certain dimensions. So how does this actually work? At a very high level, the basic idea is every Chrome user can opt in to provide some telemetry back to Chrome on its usage, performance, and all the rest. And when the user opts into that, we collect the URLs that you visit and annotate them with some performance metrics, very high-level performance metrics that are rooted in the WebPerf standards. And once we get the URLs on Google servers, we cluster them, we anonymize, can anonymize every URL, remove any URL that is not public. So we look at the things that we crawl on the web. It's useful to have a copy of the web lying around in search so we can actually cross-reference those things and exclude any authorized URLs and other things. And then we aggregate all the data into an origin rollup, and we publish that public data set. So it's a lot of hand waving, but let me walk you through some of the examples. So today you'll find a number of tools that are now starting to feature this data across all of our Google properties. And the key aspect here is historically you really had kind of two ways, or you have two ways to measure performance. One is in the lab, right? So you make a certain set of assumptions about who your user is, certain characteristics, maybe network properties, CPU profile, or all the rest. And you encode that in your infrastructure, and then you maybe run on every commit set of tests and see if there's any regressions. And that's useful. The challenge with that configuration is that you need to pick a representative user, which is incredibly hard, as all of you know, because there's no such thing, right? There's always a distribution of people. So you really need to ground that in real user experience measurement, where you need to continuously monitor how are the actual users perceiving my site, and then kind of calibrate your lab so it matches at least some of those categories or profiles. So in our tools, Google has many tools and opinions on how developers should optimize their site. We care about the health of the web. And I don't think it's a surprise to you guys that we've also heard lots of complaints that they're not consistent, right? And like one tool says, hey, we believe that a representative user is on 3G, when another tool says it's on 4G. And it's like, Google, come on, like, talk to each other. Figure out what you want the web to do. So what we're doing is we're pivoting all of our tools to have kind of a dual mandate that looks at, here are the audits that we've ran in a lab environment. Here's the real world data that we saw from Chrome, and then let's try and unify those so we can cross-calibrate the two. So a couple of examples. If you guys are familiar with PageSpeed Insights, this is probably one of the more popular tools that we like to beat developers over the head with. So if you go to PageSpeed Insights and type in any URL, it can be a landing page, or it can be an origin homepage, it can be any particular page. One of the things you'll find at the top here, and this is actually looking at LinkedIn, which is kicking ass on its Lighthouse audits, so apparently you guys are doing something right. Right underneath, there's the field data. So the field data is actually coming from the Chrome User Experience Report. This is real users using Chrome, visiting LinkedIn, and in this case, at the top, the field data in the top half is for the particular landing page. So this is specific to that page. And then right below it, there's the origin summary. So this is all pages that grouped under LinkedIn.com. You see a little bit of a difference. So when you look at the origin-wide, more users have a fast user experience on first contentful paint. So if you guys are not familiar with the metrics, first contentful paint and first input delay that we're capturing here. And the green bar represents what we call fast, which is users that saw a first paint in under 1 second. So when a user first navigates, we expect or we want to see something paint on the screen under 1 second. So this is not a full histogram, but it kind of gives you a rough breakdown of what the big buckets in that histogram are. So this is a really good example. As I was preparing the slides, I was hunting around for something that doesn't look as rosy, and it didn't take me long, and this made me incredibly sad. I did not know you can actually get a score of 1 in Lighthouse until today. But achievement unlocked. I had a little bit of a cry when I saw this. So CNN.com is not doing too well. And if you look at the field data, you'll see that only 1% of users see a first paint in under 1 second. And this is real users visiting the site. So there's truth to the zeitgeist of like the web is slow. Like if you're browsing to your favorite news site and this is the experience that you see, where 46% or 42% of all the page loads take more than 3 seconds to load, that is not a good experience. And that is definitely a case where we need to shine the light on like what is it that's happening there. Because while it's easy for me to blame CNN.com, there's probably more systemic problems there. There's probably groups of examples like that. We really need to dig in and figure out, is the web platform actually not meeting the needs of those developers? Are there primitives missing? So it's really helping us even prioritize some of our own web performance work at the platform level. But at the same time, it also gives some credibility to us going to these developers to say like, hey, yes, previously we could run your lab results or we could run lab audits, but look at the real users. Like this is the truth, right? And some sites don't even have a real user experience measurement installed. So this is an easy way to get that, and you can access this for any site. Another tool that you guys may or may not be familiar with is Test My Site. This one is geared more towards a product manager C-level audience. And the goal here is less about targeting the developer in the organization to tell them how they can improve it, and more about how do I convince my organization to actually care about speed. So it abstracts a lot of the technical documentation. You just come here, you type in your site, you can type in a couple of your competitors. In this case, I just picked a couple of random companies in the area, Google, LinkedIn, eBay, and you see how they stack up in terms of real user experience. And then the tool also provides some calculators based on some models that we've built a couple of years ago on how speed affects your bottom line. So if you're trying to sell something, what is your conversion value? How does speed relate to your conversion value? And what could you get out of it? And we find that this is a really good way to get your product managers or C-level people just even thinking about helping them quantify speed. So that's another tool. And then finally, kind of the very low-level access that we publish are the actual raw data sets. So if you're familiar with BigQuery, it's our big data, I guess, warehouse that we host. We publish a monthly snapshot of our database. It's public, you can query it. So I'm going to walk through a couple of examples here. Right now, we track about 5.5 million origins. So that's five of the most visited origins on the web. Users browse to more than that, but based on all the thresholds that we've done to anonymize all the guilty, we have about 5 million origins today. And this number continues to increase as we get a little bit better at improving accuracy and detection of all the logic. So we've been publishing this data for about a year and a half, and there's now some really interesting stats in that data. So I'll just give you kind of a taste of what you can do with this data. It's maybe a little bit hard to see, but here what we're looking at is kind of a similar view to what we saw in PageSpeed Insights, where we actually published the full histogram for each origin. So you can see how, for example, the first contentful paint distribution looks like for Google.com. So if you're ever curious about who's faster, is it Bing or Google, you can come to the Chrome User Experience Report and query for that. And at least on the global scale, when I run this experiment, you see that Google.com comes in at about 84% of first contentful paints happening under 1 second. Bing is very close in 81, but then you can really dig in here. On the left, you see the country data sets. One of the things that we offer, we provide a global view where we aggregate all the users using Chrome. But then we also do GeoIP resolution for each user, and you say for users that are visiting this domain from this country, what is their experience like? And if you dig in, if you run this same query for a bunch of other countries, you'll find some very interesting differences. Like there's definitely areas where we have lots of work to do and Bing is doing really well, and vice versa. So there's some really interesting competitive analysis that I've seen done based on this. Some CDN vendors are using this to great success to benchmark themselves and others and figure out what are the opportunities, both to upsell their clients or maybe convince other clients to come on board. It's a really interesting space right now. Here's the kind of similar example that I showed you before. This is LinkedIn.com. So I'm just querying for what is the first contentful paint, what is the density of the first contentful paint under 1 second, and specifically for LinkedIn.com. So this is basically the PageSpeed Insights report that I showed earlier, just kind of at a low level for what you can do. And what I thought was interesting is when I look at the actual results, apparently LinkedIn's doing something right, because if you look at from the bottom, right, 2017, this is when we started publishing the report, about 36% of user sessions or page loads were happening under 1 second. And as you kind of go up, like sure, it fluctuates a little bit, but you can see a trend, right? And right now it's about 55%. So kudos to you guys. You're doing something right. Woo! Which is probably why we're having the meetup here too. There's a good correlation between a performance meetup and improvements in performance. So if you want to improve your site performance, just start hosting a meetup. The rest will happen, right? Here's a slightly more kind of different view. So alongside some of the metrics like first contentful paint, first paint, onload, and a few others, we publish dimensions like what is the network profile of the user? What is the type of device? So we report mobile, desktop, and tablet. And you have country and network. So for network, we use effective connection type. So if you look at the actual data, it'll say slow 2G, 2G, 3G, 4G. It doesn't actually mean that the user is specifically on a 4G network like LTE network. It just means that the user is on a network that exhibits properties as if it's a 4G network. So the RTT maps to a certain band. The bandwidth experiences maps to a certain band. Because we've seen so many cases where you may be on Wi-Fi, but it's just so slow that the fact that it's Wi-Fi gives you no signal, right? Really what you're trying to figure out is what is the effective RTT of the user. So in this case, we're also looking at LinkedIn.com, but what I've done here is I pulled out, first of all, at the top, I'm querying the global data set and also querying the US data set. And then later, I'm pulling in the form factor And if you look at the bottom, you can see that globally, at least for users visiting LinkedIn.com, there's about 49% of them are visiting on mobile, but in US specifically, it's about 17%, which is really interesting and allows you to do some interesting comparisons. So clearly, there's some countries where that number must be a lot higher, right? I did not do the exact analysis to figure out which countries that is, but with a little bit of work, you could figure that out. So some of the examples that I showed here, there's lots more. Rick Viscomi, who's on my team, has actually published a Crux cookbook, which you can find on GitHub. And it contains some of the examples that I've shown here, plus lots of others where you can just copy paste this code, run it, and just replace your origin with whatever you care. So there's some really interesting data to explore here. Finally, if writing SQL is not your thing, we do have other tools that lower that bar. So let me see, we have a little bit of time. Maybe I can actually attempt a demo here. So we have the Data Studio dashboard. So Rick has a great write-up on a number of great presentations and write-ups on how to leverage Crux to extract insights. This particular guide, let me just guide you through it. So we can create a custom dashboard for a particular origin, uses Data Studio, and it has an integration, and it connects directly to BigQuery. So let me make this a little bit bigger. So we're actually working on making this easier so you don't have to click through these things. But today you just have to type in the origin, hit create report. And this effectively what this does is it creates a custom dashboard, if you're familiar with Data Studio, which pre-populates the report with a number of key dimensions and key reports. So let's just give it a second. So here's it's effectively the PageSpeed Insights, but now with an added dimension of time, right? So you're looking at LinkedIn.com, you're looking at first contentful paint, you can see that the number of slow sessions, which is over 2.5 seconds, is fluctuating around 10%, which is kind of interesting. It'd be an interesting follow-up to see if you segment this by mobile versus desktop or by country, are there significant differences in that respect? Also, we can look at things like device distribution. So we just looked at the specific SQL query for that. But here it is. This is global. So this is not US, this is global. So there's some fluctuation here. And we actually observed some really interesting seasonal fluctuations across all the top sites where around certain times of year, you see definite dips in different factors, which you've probably observed in your sites as well, but it was really interesting to validate that against kind of the broader web. And even more interesting when you could segment that by particular verticals like e-commerce and see very interesting seasonal trends, which in some cases that I know actually helped put out some fires where people were just like, oh my God, why are metrics crashing? It's like, well, don't worry. It seems like everybody in your cluster is crushing. So it's probably a seasonal thing. Connection distribution is a really interesting one. This is what I referred to earlier, 2G, 4G, 3G. So let's just give that a second to load. As you can see, at least for LinkedIn.com, we observe mostly 4G-like connections, properties. But about 14%, although it seems to be decreasing, is still on 3G-like connections, which is hundreds of milliseconds of RTTs. So that's that. Let's go back to here. So you can create a custom dashboard for yourself. One of the benefits of this dashboard is it'll actually auto-update. So you can share it, you can embed it, you can give it to your team, and just put it somewhere. And whenever a new data set comes out, it'll automatically update. With that, that's what I had. Any questions? If there are no questions, I have a bonus round.
Can you go to the mic, please? Thanks.
Oh, God. You're going to have to come here. Sorry. Stuck.
Hey, Nick Tran from Akamai. Good presentation, by the way.
Thank you.
Quick question on the overall score that you gave LinkedIn and CNN. Like, how much of that was factored by global traffic? Like, how do you weigh that?
Do you mean in PageSpeed Insights, or which score are you referring to?
The top score, like the 98% versus 1%. The Lighthouse.
Oh, Wait, the lighthouse. Let me see if I can. I just want to make sure that I got your question here. This one, 98.
Yeah, that one. Yes.
Yeah, so this is definitely a UI improvement that we need to make. So the 98 is the lab score, right? So we run a set of tests, and we say this is what you would get if you were to run a local lighthouse. We just do it for you. The field data below is not related to the 98.
Gotcha.
Does that make sense?
Yep.
So we don't actually run lighthouse like audits live on the clients. That would just add too much overhead to the general population.
Got it. And the second question is, I think you said that you are collecting data on 5-point-something millions of websites?
Yes, so the latest data set right now has 5.5, I believe, million origins.
And
Yep.
I guess you're hoping to expand that to
Yeah,
more websites,
if you look at the actual count in our public data sets that we've published, you see it kind of steadily increasing. So as we're getting better, or as we get better at tuning our filters. But we definitely have some room for growth. But at the same time, it seems to cover most of the sites that we care about.
Okay, cool. Thank you.
Yeah, so it would be good to know if there was some kind of common thread that ran across many of these websites actually.
Yeah, so having looked at some news organizations in particular, third parties seem to be one of the most common problems based on how they're deployed. And the really frustrating part that I think we're trying to crack right now is we know the solutions exist for a lot of the problems. So for example, a lot of them put analytics and conversion as a blocking request in the head of their page. And that's a known anti-pattern that we've talked about for at least a decade. There are good solutions for that. But for some reason or another, the business overrides the performance reasons. And that's just a thing. So I think that's actually an opportunity for us as a web platform to try and rethink it. Like A/B testing on the web is an integral part of building on the web, like to make a successful website. But it's really costly in terms of performance. What if the web platform offered some sort of A/B testing capability? Like, what would that look like? I think we can do better.
Good segue to my question. So you mentioned that there are things lacking in the platform that might help individual companies with perf testing. And we noticed a good trend in the first presentation that the web was significantly lacking in the type of information you were able to collect as an individual company without having to go through Google. Are there interesting proposals coming in through standards bodies like TC39 that will be able to help us collect perf numbers on an individual basis as we see fit, that you're personally excited about?
That's a really good question. So this one requires a little bit of unpacking. So generally, it is much harder to get telemetry on the web because we have a different security model. We don't allow access to low-level network stats, CPU stats, for the reason that we don't trust the stuff that runs in the frame. Further, we don't trust the third parties that run in that frame. And because of that, that makes things really challenging in terms of what we can expose. So this is a constant struggle that we have in the Web Performance Working Group. For example, even with the proposal that the Marty's team is driving with just profiling, they've done an amazing implementation. I think our challenge there will be to figure out, in the case of Facebook, everything's first-party code, and we can trust everything. In the case of the general web, when you have third-party code also running there, what can you expose without leaking data about the state of the page? And that's a very different security model than you just installed a native app. All right, there you've already established some sort of trust, and then you have full access to that. So that's a challenge. We definitely are thinking about the space though. So I'm still hopeful and excited about, for example, Marty's work. One of the, I think, most interesting, totally unrelated APIs that we've recently shipped that very few people seem to know about is network error logging. I don't know how many people, sign of hands, show of hands, a few people. I see one. Okay, we're not doing our job, clearly. So the idea, funny enough, I actually have an article open. So if you want to search for this, Scott Helm, who runs the Report Your Rise service, actually published this really good blog post recently. And the idea here is, so you can emit two headers on your site. One is the report to, and report to is a new primitive in the web platform for allowing you to designate reporting endpoints for various telemetry. So for example, if you've ever deployed CSP before, we had a special directive for sending data. If you wanted to aggregate deprecation reports, you needed some other configuration syntax. So report to is trying to merge all of that into a coherent thing where you can declare groups, you can declare load balancing, and all these other parts. Okay, so that's one. So you define a report to, and you say, I want to send reports to whatever my collector is. The network error logging one is really interesting. What it does is it says, look, we know that there are cases when the navigation fails for a variety of reasons. It may be a DNS lookup failure. It may be the TLS certificate failed for some reason. Maybe it's something else. And the problem is you guys don't even see that, right? Because that request may not even have hit your server. So there's no way to log that. And it's actually quite shocking how many of these abandoned navigations we see in Chrome. In some geographies, we see up to 20% abandoned navigations, right? And this is like for large first-party origins. So if 1 in 5 users can't reach your site, that's a bit of a problem, right? So network error logging addresses that by allowing you to declare policy. So when the user has to visit your site first. Once it registers that policy, in the future, if it hits one of these errors, it'll use the configuration to send the report to your designated endpoint. So clearly, you want your endpoint to be on a completely different network, decoupled from your origin, so you can actually collect the report. But it allows you to get introspect those errors. And I think I can actually show you a couple of errors. So there's DNS, TCP, TLS, HTTP redirect loops. So here's an example of a report that we may send. We can say, hey, the user tried to access this new subdomain with a method get over some protocol, and the error was that DNS failed. Right? We never resolved this thing. Or we encountered a redirect loop, which shockingly happens quite frequently on the web to this day. Or maybe the certificate has expired, and the user chose not to proceed. So you can gather this data, collect it, and act on it, hopefully. And we found some really interesting, we've been using this system within Google for a while. We actually had an implementation of it, which was limited to Google properties. And now this is available to anybody to use. Yeah. Sorry, that's a long-winded answer.
So I have a pretty specific question. Both tools, Chrome UX Report and PageSpeed Insights, are great tools, but Chrome UX Report only has information for origins. At the same time, PageSpeed Insights provides some data, like performance data for individual URLs. Is there any way to get Chrome UX data for individual URLs and maybe a list of these URLs for each origin?
Yes. So PageSpeed Insights actually provides both. It gives you the URL level data and origin data. So if you look at this one at the top, the first graph, it's actually for that specific page. And the bottom origin is for the origin rollup. In the public data set, we don't publish the URLs for a variety of privacy and security reasons. We don't want to enumerate every site, every URL on the web. But if you know the URL you want data for, you can come to PageSpeed Insights and query for it. I think you may see us expose this data in more ways as we integrate this data into our tools, where, for example, if you're a verified site owner, I think it's a reasonable thing for us to expose kind of the full list of URLs. But today, this is what you have. All right, thank you, folks.
I hope all of us get a chance to go back, play around with Crux and PageSpeed Insights to make meaningful improvements to our FCP. But yeah, that was our meetup today. Please join the LinkedIn Performance Engineering group so you can catch the recap and videos of this meetup, and grab some more food and dinner and talk to more people. See you guys at our next meetup. Thanks.